Hi guys, welcome to the channel Code by Raghav, and in this video we are going to solve the lead code question number 75, that is sort colors. And it's a medium type question, and it has been asked by many companies. As you can see, there are a lot of names right here, including the big name also: Google, Apple, Adobe, Oracle, Uber, Bloomberg, Flipkart, Samsung. So it's a company favorite question because it uses an special algorithm made for this question, specially this type of question. So we will see that quickly, and first let's read out the statement what this question says. So we have given an array nums with n objects and colored red, white, blue. So we have three types of colors. Sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. So we have to sort them in place means we don't have to use any extra space. In we have to do the operations in the same given input array. We will use the integers to denote the color red, white, and blue. So 0 is for red, white is for 1, and 2 is for blue respectively, and we have to sort them in an order 0 1 2. You must solve this problem by using the library without using the library sort function. So you cannot use the sort, the linear sorting. You cannot do that because it will take the time complexity of n log n, and it is not acceptable. So we will, as you can see, first let's see the examples. We have three colors represent, we have three integers 0 and 2 and representing the colors. So we have to sort them out in the input. You can see 0 denotes the red, 1 denotes the white, and 2 denotes the blue. So we have to arrange them in the order. So let's see how we can solve this question. Before solving this question, we have to learn about what is the Dutch national flag algorithm. It's an special type algorithm used used for sorting only the three distinct integers. So what I'm saying, let me write it. Point used to sort that the array only contains three distinct integers, and so we should have only three distinct integers and we have to sort them, then we can use this Dutch national flag algorithm. Typically the three distinct value are 0 1 2. In the same example we have given 0 1 2. Let's take this three values as 0 1 2, and how we can sort them, let's see. We take three pointers, it's a three pointer based approach, and we take a low, we take a mid, and we take a high. So in the low we set the boundary of zeros. So low indicates what? It indicates the boundary of zeros. Mid will be our pointer that will move across, pointer that move across the array, and high will denote the boundary of 2's. So low will indicate, as you can see, so here you can see by reading this statement, low will indicate what? The boundary of zeros. Mid is the pointer that move across the array and will do the operation if the ele- of the element of the ith index contains what number and we have to do the operations or not. And high will indicate the boundary of 2's. So we can see from these three statements, if the low contains the boundary of zeros, let's say 0 0, and high contains the boundary of 2's, so we have obviously the mid will contain the boundary of ones, so we don't have to worry about the ones. It will automatically get sorted in the middle of those two elements. So we can see how we can do such type of operations. So let's take an example. Let me copy this example. So it's a perfect examples to for the 0 1 2 type. So this is our example. Let me write the indexing also of this array: 0 1 2 3 4 5. So we will start the low from the 0th index and the mid also from the 0th index, and high will start from the n minus 1. N is what? Size of the array. So I will write some rules in on which this algorithm depends. So make sure you carefully look at the decision rules. How these pointers will move when we do the operations, and when we have to do the operation we will also see that. So let's see, if the nums of I, if the, let's say this is our array A, if the ith index element is equal to 0, so what we have to do means, this is your low and this is your, here is your mid. So if you, this, so the mid element, what is mid element? It will pointer that move across the array. So let's say your mid is here and low is here, so you have to swap this out, means you have to place this 0 on this low position. And so what we will do, we will swap out the values of low and mid, and we will move the both pointers one step ahead, low plus plus and mid plus plus. That's our first step. If the array of I is equal to 1, if it is equal to 1 means we don't have to, we have already seen we don't have to care about the 1. It, at the end of the all iterations, at the end of the condition loop, the 1 will already present in the middle of 0 and 2. So we don't have to care about, so we do nothing operation, we just mid plus plus. So our pointer will move step. And if the array of I is 2, means where we have to place the 2, it should be in the end of the array, so we have to push this 2 to the end. And what pointer is currently standing out the end? It is the high that is standing on the n minus 1. So we will swap the values of mid and high. Take this high as mid because it is the mid pointer that is moving across the array. And what we will do, high standing here, let's say your element is 2, means it has to be go to the end of this array. So we have to swap it out with this. We will start with the mid from here, right? So we have to swap it out with the mid and this high. So we swap it out, 0 comes here and 2 comes here. And the high will move backwards. So when the a of I equal to 2, after the swapping we will move the high backwards. So this is our the 3 rule algorithm. It's a very easy algorithm. It just says if the 0, swap it out with the low pointer and move each pointer ahead, the low and mid. If it is 1, we don't have to care about, just let mid go on. And if the mid is 2, we have to send to the back of the array, and we will move the high backwards. So that's the basic approach. We are doing the sorting. We are placing the 0 ahead of the array and placing the 2 at the back of the array, and the 1 at the end is always in the middle. So let's see a quickly dry run. Let me take this example picture again and we will see. So this is our picture. So let's say, let me do the indexing 0 1 2 3 4 5. We will, so the low is at 0 index from initially, and the mid is also initially at the 0th index, and the high will be the end of the array, means n minus 1. So what is the array of mid is current? It is 2, means we have to send this 2 to the back of the array. So we have to swap it out with this high, with the mid and the high. So the 2 come here and the 0 will come here and the high will come here. H means high. And now next iteration is, now we have the array of mid is 0. After the swapping, the value gets swapped and it is 0 currently. If it is 0, means 0 should be at the starting of this array, so we have to swap it out the low and the mid. The low and the mid and currently in the same position, is doesn't matter to swap it out. So after the swapping, it will move step both pointers. So low will come here, mid will come here. Now again, and now the area of mid is here at 1 at the index. The value is 0, it should be in the starting. So we will swap the low and mid. Low and mid are on the same position. So after the swapping, it will go one step ahead. Now mid, sorry, not H, it should be M. Now we will ask area of mid is 2. 2 means it should be on the back of the array. So we will swap the values of area of mid to the area of high. So that's 1 will come here and the 2 will come here and the high will come here. Now we will ask the area of mid is what? Is currently 1. If it is 1, We don't have to care about 1, just move the mid ahead. Now it is equal, m is less than equal to h, so that's our condition breaking rule. Now we out of the loop. Now you can see the output. We have the array sorted. Let me write 0 0, this 1, the 1 2 2. We have the output, and we done the swapping in O of 1 space in place sorting. And for the time complexity, our mid is visiting the each element only once. At the worst case, it will visit the each element only once, so the time complexity will be O of n. So let's quickly code it out, this question. Now let's write the n. Let's calculate the size of the array, and let's write out our 3 pointers. Low will initially from 0, mid is also start from 0, and the high will start from the n minus 1. What's the loop condition? Low, sorry, mid will be the pointer that will move across throughout the array. Mid is less than equal to high, and if nums of mid is equal to 0, means we have to do the swapping of low and mid, nums of low and nums of mid, and increment both pointers, low and the mid. The next condition, else if the nums of mid is equal to 1, means we don't care about 1, just increment the mid. At the end, 1 is always in the middle. Just move forward your pointer, and else if the nums of mid is equal to 2. In this question, as you can see, we have only 3 distinct element integers, 0 and 2. So 0 condition done, 1 condition done. The else case is obviously for the if the nums of mid is equal to 2. So for the else means we have to send the 2 to the back of the array. So nums of mid to the nums of high, and the high will move backwards. That's it. Let's try to run it, and let's see if this test cases are accepted. Let's try to submit. Let's see our submission is accepted or not. It is accepted. So you have already seen the time complexity. Our mid is visiting the each element only 1 at the worst case, so time complexity will be the O of n, and the space complexity, we are doing the in place sorting, so the space complexity is O of 1. So thank you for watching. Make sure you like, share and subscribe. Thank you.